A SpaceX Dragon capsule is grappled by the space station's robotic Canadarm2 on April 10, 2016. Click for full view photo. Credit NASA Cape Canaveral, Florida. The cargo aboard NASA's scheduled August 14, 2017, commercial resupply mission to the International Space Station ISS could help more people than just the 6 astronauts and cosmonauts currently living there. With more than 3 tons of experiments and materials being ferried, SpaceX Dragon capsule promises to benefit people ranging from those suffering from Parkinson's disease, to those seeking bioengineered organs, to soldiers on the battlefield. NASA astronaut Jack Fischer works within the Japanese experiment module on crs-12. crs-12 will utilize the orbiting laboratory's microgravity environment to grow larger versions of leucine repeat kinase 2 (LRRK2) implicated in Parkinson's disease. Photo caption. Credit NASA. In 2008, NASA awarded 2 contracts, one to Orbital Sciences, now Orbital ATK, and one to SpaceX, for commercial resupply services to the orbiting lab. At the time of the award, NASA ordered 8 flights from Orbital, valued at about $1.9 billion, and 12 flights from SpaceX, valued at approximately $1.6 billion. SpaceX flew its first mission under the contract in October 2012. Orbital flew its first mission a little over a year later in January of 2014. The crs-12 mission is currently targeted to launch at 12:31 p.m. EDT 1631 GMT on August 14. When it flies, it will mark the 12th ISS resupply mission that SpaceX has carried out. 1 commercial orbital transportation services mission and 11 commercial resupply services missions have successfully traveled to the space station. The company's Dragon spacecraft will ride a full-thrust Falcon 9 rocket, roaring away from Kennedy Space Center's Launch Complex 39A. Assuming an on-schedule launch, the spacecraft should arrive at the ISS on August 16 with some 6,415 pounds (2,910 kilograms) of cargo. Only about a quarter of the manifest will be crew supplies, vehicle hardware, spacewalk equipment, and computer resources. The remainder of the spacecraft's manifest is comprised of hardware and supplies to support dozens of the approximately 250 science and research investigations that will occur on current and upcoming ISS missions. NASA hosted an August 8 pre-flight science briefing featuring the principal investigators of 5 of these experiments. About a third of the crs-12 cargo mass will be a refrigerator-size package designed to measure dangerous, life-threatening cosmic rays. This project, called the Cosmic Ray Energetics and Mass Investigation (CREAM), features instruments to measure the charges of cosmic rays ranging from hydrogen nuclei up through iron nuclei over a broad energy range. According to principal investigator Yoon Suk-seo of the University of Maryland Institute for Physical Science and Technology, once the ISS astronauts unpack it, the modified balloon-borne device will be placed on the Japanese exposed facility for a period of at least 3 years. According to NASA, humans aboard long-duration, deep space explorations such as those to the planet Mars are thought to likely face serious health consequences from exposure to high-energy galactic cosmic rays, including direct damage to DNA and changes in the biochemistry of cells and tissues. Seo said that people on Earth are protected from these rays by the Earth's atmosphere and magnetic field to the extent that some solar radiation does get through. It is roughly the same as that of starlight. Mice for NASA's Rodent Research 9 experiment will reside in a rodent habitat module while aboard Dragon and the International Space Station. Photo credit. Dominic, Hart. NASA. Even astronauts aboard the ISS are somewhat protected by the Earth's magnetic field. However, beyond the outer zone of the Van Allen radiation belt, extending 8,100 to 37,300 miles (13,000 to 60,000 kilometers) from Earth, long-term exposure is thought to be very serious, according to the space agency. CREAM experiments conducted in 6 balloon flights at 25-mile (40-kilometer) altitudes over Antarctica have yielded a limited understanding of galactic cosmic rays. The 3-year CREAM mission aboard the space station will significantly expand knowledge of cosmic radiation and what it might take to protect interplanetary travelers in the future. As many as 1 million Americans live with Parkinson's disease, with a worldwide total thought to exceed 10 million. One of the experiments aboard crs-12 is aimed at helping to find a cure for this affliction. One aspect of Parkinson's under investigation involves a protein called LRRK2. Defining the shape and morphology of this protein would help scientists better understand the pathology of the disease and aid in the development of effective therapies that might slow or stop the progression of this neurodegenerative disorder. Unfortunately, according to Marco Baptista, Director of Research and Grants for the Michael J. Fox Foundation, Earth-grown versions of the LRRK2 protein are too small and too compact to study. However, Baptista and other principal investigators from the University of Oxford, Goethe University Frankfurt, and the University of San Diego believe that versions of the protein grown in microgravity may be larger and better defined, lending themselves to detailed analysis. Aboard the ISS, a CASIS-PCG-7 automated biotechnology device will produce samples of the LRRK2 protein. The project hardware includes a microlithic crystal former optimization chip 16-channel plate. It will be launched frozen and then transitioned to ambient temperature on the ISS to start the nucleation and crystallization process. Following a growth period of up to 21 days, the hardware will be moved to refrigerated storage for the return flight to Earth for detailed laboratory analysis. Another experiment aboard crs-12 is focused on helping solve health problems. This one relates to the use of stem cells to grow replacement lung tissue in patients with lung diseases or conditions. Joan Nichols, a professor of internal medicine and infectious diseases and associate director of the Galveston National Laboratory at the University of Texas Medical Branch Galveston, provided a brief explanation. According to Nichols, the cells will be flown live in tissue culture bags to the ISS via conditioned stowage assets at 98.6 degrees Fahrenheit 37 degrees Celsius within biocell habitat containers. Once on board, the biocell habitats will be placed inside chambers that should provide temperature and carbon dioxide control for the cell cultures. Kestrel I will test the possibility of building and launching clusters of small, relatively inexpensive satellites that have sufficient optical capability to provide useful, real-time information over an extended period of time. Photo credit U.S. Army. The cells will be cultured for approximately 5 weeks with periodic sampling. Once the cultures have grown for a predetermined amount of time, a 4.5 ml sample will be pulled from the bag and frozen at -176 degrees Fahrenheit -80 degrees Celsius for the remainder of the flight, and then -68 degrees Fahrenheit -20 degrees Celsius or colder for return. The cells remaining within the bags will also be stored for the return flight. The stem cells won't be the only live cargo aboard crs-12. As was explained by Michael Delp, principal investigator for Rodent Research 9 from the Florida State University, 20 mice will be the focus of an investigation related to musculoskeletal and neurovascular systems of astronauts in long-term interplanetary travel. Delp noted how this experiment is aimed at 3 particular biomedical aspects: visual impairment caused by lack of sufficient movement of fluids in the brain, fluid movement into and out of the brain, and biomechanical movement, especially in cartilage tissue. Delp said that rather than collecting data from the mice, the plan will be to observe the behavior with video monitoring. Further, he said the mice would be brought back alive for a splashdown in the Pacific Ocean and then rushed for observation and evaluation to the office of Co Wen Mao, one of the co-investigators, at Loma Linda University. One final project covered during the August 8 science briefing involves space-based support for the military. Chip Hardy, Kestrel I program manager for the U.S. Army Space and Missile Defense Command Army Forces Strategic Command, presented an overview of providing real-time information to ground troops regarding enemy location and movement. Currently, there are military satellites that can provide fairly detailed visual images or video. However, these satellites are very expensive, relatively few in number, and provide useful information only if in the proper orbital attitude. The NanoRacks MDC Kestrel IIM project will test the possibility of building and launching clusters of small, relatively inexpensive satellites that have sufficient optical capability to provide useful, real-time information over an extended period of time. According to the NASA media briefing release, it is a monolithic design, with dimensions of 15 inches x 15 inches x 38 inches 38 centimeters x 38 centimeters x 96.5 centimeters with integrated command data and handling system, attitude controls and solar arrays for power. The primary payload is a medium-resolution electro-optical imaging system, an element of which is a commercial off-the-shelf COTS telescope. Following an anticipated October 2017 deployment using the ISS NanoRacks Caber deployer, the NanoRacks KIM will begin its nominal mission operations limited by its expected 6-month orbital lifetime. There may also be civilian applications for this potential optical platform, such as to monitor the weather and natural disasters. If this test is successful, Hardy noted that the next step might be one of a number of alternatives, including a low-volume production run or the substitution of a different optical technology. Video courtesy of the Center for the Advancement of Science in Space tagged crs-12 Dragon International Space Station. Lead stories. NASA SpaceX. Jim Siegel comes from a business and engineering background, as well as a journalistic one. He has a degree in mechanical engineering from Purdue University, an MBA from the University of Michigan, and executive certificates from Northwestern University and Duke University. Jim got interested in journalism in 2002. As a resident of Celebration FL, Disney's planned community outside Orlando, he has written and performed photography extensively for the Celebration Independent and the Celebration News. He has also written for the Detroit News, the Indianapolis Star, and the Northwest Indiana Times, where he started his newspaper career at age 11 as a paperboy. Jim is well known around Celebration for his photography, and he recently published a book of his favorite Celebration scenes. Jim has covered the Kennedy Space Center since 2006. His experience has brought a unique perspective to his coverage of first the Space Shuttle program, and now the post-shuttle era, as U.S. space exploration accelerates its dependence on commercial companies. He specializes in converting the often highly technical aspects of the space program into contexts that can be understood and appreciated by average Americans.